All right, good afternoon. So we're looking at factoring. Again, I know we've done factoring before, but we're looking at factoring, but in a different context in terms of a different way of factoring polynomials. Now, we're going to be looking at something called factor by grouping, and we're looking primarily at polynomial expressions right now. And what that means is we're going to definitely have four terms, and really and truly, this can be done with four or more terms. It can be done with six terms. But we're specifically just focus on four terms, okay? And so the idea is to be able to break apart a polynomial into its factored form, as simple as possible, okay? So the basic steps essentially will be to factor out a GCF if possible, if we have one. That's always going to be a first step whenever we do factoring, because that makes things seem easier to work with. We're going to group first two terms and last two terms, okay? And the one thing about the grouping is that it doesn't even have to be the first two or last two. It is possible to rearrange in order to regroup a different way. But for the most part, I think we're going to, again, trying to make this just for you to get the idea across about what grouping is and factor by grouping is. Then we're going to factor out a GCF from both sets of groups that we have. And what should happen is you should have a binomial term that's going to be the same for both. Okay, and you'll see that here in a second. So it'll look something like this. You have a four-term polynomial. In this case, this is a third degree or a cubic. We're going to group according to the first two terms and the last two terms. We're going to take a GCF out of this set only, and then a GCF out of this set only. And they're going to rewrite the GCF terms into one factor, and then the same binomial, the binomial that's the exact same, into a second factor. Okay, and then we have factor by grouping. That's the main idea of the main process. Sometimes, if you factor by grouping, it is a possibility that you may be able to factor out even further. And one of the big ones that you see quite often is difference of squares. So it looks like this, okay, where you can take the square root of both of these to get x plus 1 and x minus 1. So a full factor would be x plus 2, x plus 1, x minus 1. Okay. And so that's something that you're going to see on these as well. Okay, so now, again, we're doing mainly with four terms. Okay, it can be done with more than four, but we're going to basically focus on four. And we definitely need to know how to do GCF. And then at the very end, you could have a difference of squares term that we need to take one step further. Okay. All right, so here's how it works. Okay, so I'm going to take these and I'm going to regroup them. And I like to use parentheses when I do this. I'm going to regroup them like this. Okay, so the first set I have, and I'm going to rewrite it so you can kind of see it, is x plus q plus 6x squared. And the second group I have is going to be minus 5x minus 30. Okay, that's the way I have it broken down. Let me rewrite this. So in the first set, I'm looking at this for a GCF. And in this case, I have x squared and x cubed, which means I can take out of both of these two terms, x squared. And it means that in the first one here, I would have x plus 6 left over for my first factor. Okay. In the second term, I can take a 5 out of both of these. Now, one of the rules I'm going to tell you is that if the first one right here is negative, we want to make sure and we take out the negative with it. So this becomes a negative 5. And then this would become x plus, and if I divide negative 30 by negative 5, it becomes a positive 6. And what you should notice is that this term and this term are the exact same. Okay. So now to write this, I'm going to take my two GCF terms, which are this guy, this term, and this term, and I'm going to rewrite that as one factor, x squared minus 5. And I'm going to take the term that is the exact same, x plus 6, and I'm going to write that as another factor. And that's it. Now, this one right here, I could take one step further, but since we're only gonna worry about perfect squares and divisible squares, I'm not gonna take it any further. So this is what essentially what I want to see is just basically, can you break it down into two simpler factors? Okay, and that's it. So on this one, first thing I want to do is look for a GCF. So is there a value you can take out of all four of these terms? And there isn't because of the 5. So I'm going to move on to the next step. So I'm going to go ahead and regroup like this. That's one group. And then the other one is going to be that group. Okay. Now, could I do this a different way and get the same results? Yes, you actually could. You could rewrite this and regroup them differently. But again, if you go with this route, it should work most of the time. Okay. So here I can take a 2 and this x squared out again. So I'm going to take a 2x squared as my GCF out. That'll leave me with 6x plus 1. Here, again, because the first one's negative, I'm going to take out a negative automatically. And I'm going to divide both of these by 5. And if I divide this by 5, that gives me a 6x. And if I divide this by 5, plus 1. And again, these two terms should match up. Now I'm going to rewrite my terms again. So this GCF term and this GCF term will become one term. And then the two terms that are the exact same, and there's your factor terms. And again, I could take this one step further. We're not going into solving or anything like that. We're just rewriting it as factors. Okay. Again, GCF, I can't do anything because of this x. So I'm just going to rewrite. Now, when you get used to this, you could kind of skip some steps. A GCF here would be 8 and x squared, so 8x squared. And that would leave me with x minus 8 as that term. Here, because I can't actually take anything out, it's automatically plus 1. And that would leave me with x minus 8. So if I can't remove anything, it's just going to be a plus 1 automatically. Okay. And again, these two terms should match up. So my GCF terms are what I'm going to rewrite as my first factor. And then my two similar terms will be my second factor. Okay. And again, I'll just keep going. I'm going to keep removing. I'm going to skip one step. I'm going to go ahead and group the first two together since that's kind of what we've been doing. Okay. The first set, GCF would be x squared. That's going to leave me with an x plus 3. Again, negative, so I'm going to automatically take a negative, in this case, 9 out. And that would leave me with an x plus 3 because if I divide negative 27 by negative 9, that's a positive 3. And because I know that these two should match up. So my first two terms would be these right here. So x squared minus 9 is my first factor. X plus 3 is my second factor. Now, here's one thing I do want to notice. This is the difference of squares right here, which means I can take that one more step and make that an x plus 3 and an x minus 3. And then this term will come down as an x plus 3. So these two come from the x squared minus 9, and that's where difference of squares come into play. So this would actually be your simplified full factor form. Okay. Okay. So what happens when you have higher degrees like these with 6 and 5? You don't change anything up. Because there are 4 terms, Again, I'm going to do the same thing I've been doing, where I'm going to group the first two together, and I'm going to group the second two together, and then I'm going to still do my GCF. Now, in this case, we know 2 is part of it, but because this is x5 and x6, I can actually remove the x5 out of there. And if I do that, that would leave me with x plus 1. Minus x, so the first thing I know for sure this is going to be a minus. And in k, since I don't have anything in common, it's automatically a 1, which makes this an x plus 1 as well. So these two would be similar. Those two will go together as your factor GCF. So there's one factor, and there's another factor, okay? And that's what factor by grouping pretty much is. Regrouping a polynomial in order to reduce out and take, or GCF, greatest factor out, and then rewrite as 2 simpler factors, okay? If you can take it all the way through with like a difference of squares like this, then we can. This one I could have done it that way, but again, since we're going to try and stick with the perfect squares right now, I'm not going to take that any further. Okay. So how does it get any more complex, you're asking? Well, what happens when you have multiple variables like these? You don't really change anything up. So what you can do is you look to see, can I regroup these in any way that'll make this a little bit makes more sense. So like, for example, this 15xy and this negative 5xy, since they're both 5s, I could regroup those together. And this 6x squared and this minus 2nx, I could regroup together because they're both evens, okay? I could do it that way. I could put the first two together like I've been doing and reduce those by 3. There's just different ways of doing this. So I'm going to show you how you could do it if you were to rewrite it. So if I rewrote it and I put my 5s together instead, and I put my evens together, so 6x squared minus 2nx, okay, then I can look and see what is the common terms that they would have for each one. So here I know I can reduce GCF of 5 out. I can also GCF of a y out. And if I do that, that will give me 3x here minus n. Then here I can reduce a 2 out and an x. And then if I did that, that will give me a 3x minus n here as well. So again, notice how I rewrote it, but my terms still were similar in that result. And so my factored form would be 5y plus 2x and 3x minus n. Now, normally, whenever you have multiple variables, you're not going to really run into things like difference of squares, although it is doable. But that is, that. Again, same thing. I could just do the first 2 terms. I could do that. Now, here's one thing I do want to show you that makes sense. That'll make it a little bit easier to do. See how there's a 6, a 36, a 6, and a 36? I could actually remove a GCF first doing this. If I do that, this becomes 6, and this becomes AW minus 6AK plus B squared W minus 6B squared K. And then I can group accordingly. And in this case, I'm going to just group the way they are. I'll put those 2 together, and I'll put these 2 together. Okay. So then this becomes 6 times, actually, I'm going to write that last. So this would become A times W minus 6K plus B squared times W minus 6K. And again, these 2 should match up if you do it right. So then my 2 GCF terms. So that would become A plus B squared as one factor, W minus 6K as my other factor. And again, remember that 6 in the very beginning? That would just go out in front like that. So that's factor by grouping. It's a simple process. There's not a, you just need to know how to do a GCF. And then a grouping process, again, there's really a multitude of ways you can do it. But if you really just stick to the first 2 second two, I think that makes it, makes things a little bit simpler for you. So, all right, that's all I have for y'all today. We'll see you later.